Hello everyone and welcome to DareCraft. This is a channel about efficiency and conserving resources, but most importantly, efficiency. Today I will be presenting my ultimate minecart sorting system. This is it, the ultimate minecart sorting system. It is based on Mumbo Jumbo's minecart sorting system, and it does 20,000 items per hour. And how did I get that number? Well, I ran it through 6 full double chests of items. That's 6 times 54 times 64 items, which is approximately 20,000. Why do I call it the ultimate minecart sorting system? It's because it only uses 4 main ingredients. The first one is redstone, this is a redstone machine, and it is easily obtainable from mining or trading with villagers. The second one is iron. As you probably know, you can build an iron farm on day 1, so it is not exactly a scarce resource. Gold might be a bit scarce, but you find plenty of it in the nether, and you can also build a gold farm with zombie pigmen, etc. Then the quartz is also a bit harder, but also renewable. You can build a zombie piglin trading farm and mine a lot in the nether to get these. So here are the wool colors and what they mean. The yellow wool is for loading the minecarts. The blue wool is for returning and preparing the minecarts. The orange wool, which is a new one, is for the safety systems. The lime wool is again for the unloading system, and the magenta wool is for the sorting system. Let us start with this preparing and loading unit. As you can see, it has 3 colors of wool. It has the returning, the loading, and the new orange safety line. So first, the minecart is returned here, and immediately it passes under a chest of wooden shovels. It collects 5 shovels, and 1 is removed by this hopper. And it comes to this gate. To save resources and space, I have changed the item elevator for the shovels to a traditional torch tower elevator. It is not really perfect. It click-clacks now and then, but it does the job just fine. To understand why this gate is needed, we first have to understand how the items are loaded. This is the input chest, and underneath it is a hopper minecart in a block. The hopper minecart is so positioned that it rests on this detector wheel as well, so that if there is an item in it, then a signal will be sent to this comparator, which powers this block and opens the fence gate. Then, when there is at least 1 item in the hopper minecart, the minecart here will travel to the loading station and pick up that item. However, unlike Mumbo's system, the minecart has 4 shovels inside, which means we cannot find a critical point for it that will ensure it is launched even if there is 1 block in it. Therefore, we have to add an additional redstone line down here. This is a simple repeater delay. So when the minecart comes to this detector wheel, it means that there is at least 1 item in the hopper minecart up top. And that after 5 repeaters and some redstone torches, the gate will be opened. This means that if the minecart comes, then regardless of whether it is full, after approximately 5 repeater delays, it will be launched. Over here is the same comparator system that we've seen in Mumbo Jumbo's system, although I used a barrel instead of a hopper to save some iron. Up here is an observer sending a redstone signal into this block, and this 4-tick repeater takes the signal out of that block and powers this fence gate, releasing the minecart. That is all for the loading system. Now Now let's look at the sorting and unloading system. This is the biggest reason why this system can do 20,000 items per hour continuously, while Mumbo's system can only slightly beat a single hopper line. Remember when Mumbo said,
So I guess the main point of inefficiency with a design like this is when the hopper minecarts are moving. So right now they aren't doing any item sorting, they are just moving around.
That's actually what I've done here. Only the change isn't exactly to speed up the minecart delivery time, it's to unload the items while the minecarts are en route. If you recall from my minecart unloading and loading systems video, minecarts are faster unloaded by a buffer, such as a hopper minecart. But in this case, we can't use hopper minecarts. The reason I will explain in a second. So instead, I have had to make do with 2 hoppers unloading the minecart together. Again, if you go back to my minecart unloading system video, you should know that a minecart on a slope before a fence gate will be in a position that is over both of the 2 blocks, which is exactly what happens here. The minecart stopped by this fence gate will have its items unloaded by this hopper and this one as well. The hopper in front will push its items into the hopper in the rear, and this comparator will detect if this hopper has at least 1 stack plus some items. How does it do that? Over here is this barrel acting like a chest filled with 3 shovels and 55 items, which makes this comparator right on the brink of 1 stack and some items. So what that means is that as soon as this buffer hopper fills up with 1 stack and some items, then this piston will extend, which will send a redstone signal to this redstone dust, which is detected by this observer, and that powers the fence gate, releasing the minecart. And how do we know that the minecart can be released when there is 1 stack and a few items in the hopper? Well, it's because our minecarts are structured so that the item it's sorting is in the first slot and it's all shovels in the rest of the slots. So when a shovel is unloaded, we know that all the items have been unloaded or are in the buffer. And down here is the same big item filter that we saw in Mumbo's system. However, it is a bit twisted to accommodate for all the things going up above. This sorting system is also the same as in Mumbo's system. However, this hopper elevator is the cause that we cannot use hopper minecarts in this system. Here is what I've seen during marathon tests with the hopper minecart system. The item in the sorting either gets stuck here or stuck here. This means that the tick generated by the comparator is not sent throughout the droppers, or that the tick generated by the comparator turning off arrives at this dropper before the item arrives. That is completely due to lag. If you're thinking, boo-hoo, this guy needs to get a new rig, then let me show you my F3 screen. As you can see, my CPU is a 32-thread Intel i9-13950HX, which is a very beefy CPU, and my graphics card is an NVIDIA RTX 4000 Ada. This is technically a professional level graphics card, and it is equivalent to a 4080. So we can conclude that this item elevator is not inherently stable, and it is the reason, or rather the bottleneck, of the efficiency of this system. And lastly, let's look at the fail-safe features of this system, or the orange lines. A disclaimer that on the emergency line, the system also comes with an off switch, so This does not mean the entire system is in a lockdown state. It just means it's shut off. Let's start from the top. These two orange lines are for the exact dropper elevator problem that I talked about over there. So, when an item isn't returned to its chest, one of these redstone torches will be lighted, and that sends a redstone signal directly back to this comparator right here, and that locks the comparator, which closes this fence gate, stopping the minecart right there. Now I'm in spectator mode. Let's look at the overflow protection system. As you can see, each of the output helper lines has one comparator reading from it, like that, and another comparator reading out from the chest going into that. So what this does is that when that hopper fills up with at least 23 items, then this comparator is activated. Its change in state is detected by these observers down below, which activates this redstone line, and these repeaters send it all the way over to this lockdown system. How this lockdown system works is that when you apply a redstone signal of 2 ticks or more to this block right here, it turns off this redstone torch, which allows this comparator to power the block, and that locks itself in a on state. This redstone torch also powers this redstone line above, and that transmits all the way to the loading system. And so if there is a clog, such as these chests are all filled, then after you clean it up, just come here and flick that lever twice. That will reset the self-locking mechanism and allow the system to function as normal. Here is a demonstration of the lockup circuit. When I flick this lever to imitate an input 2-tick redstone signal, as you can see, this torch turns off and this comparator is powered. But when I flick this lever twice, the redstone torch turns back on, which means that this lock is deactivated. This over here is a prototype of the unloading system using a minecart. This system, however, causes so much lag that the item elevator misfires so much that it is impossible to complete even 10,000 items in transport. However, this system is much faster. In my testing, half of this system transported 15,000 items in an hour. Imagine it. If both halves are operational, then this system will transfer 30,000 items per hour. Unfortunately, that is not possible with all the lag caused by the item elevators. And that's it for this video. The ultimate minecart sorting system with 20,000 items per hour. If you found this video interesting, please don't forget to like, share, comment, and perhaps consider subscribing. Thank you for watching.